Hi everyone. So in this video, we'll discuss slightly good level question from oscillations chapter, right? The oscillations corresponding to say a bathtub, water in a bathtub, which oscillates slightly something like this, right? It is sloshing from one side to other side. Okay. This is also valid for a very large water body like a lake. You can look at any video on YouTube. It is called as size of water, right? Size of water in a swimming pool or a lake. You can search for it and you can look at how these oscillations actually happen, right? So obviously, we will be talking about very small oscillations. So what we have in this question is a rectangular pan of base 12 is partly filled with water up to a height h. So we have a rectangular pan. And we have a rectangular tub which is filled to a height h with water as shown. When the pan is pulled a little, the water begins to slosh. Right? So you're giving some kind of small disturbance and the water will begin to slosh. Okay? All right. Assuming that the water surface remains practically flat, that means when this sloshing is happening, right? So in that particular case, suppose a little bit water has went from left to the right side and water surface is something like this. It is always flat. Okay? And that disturbance is obviously very small. You have to tell me what is the time period of that particular sloshing, right? All right. So we will do it using energy method. So we have to get the kinetic energy and potential energy of the system, right? So let us say water is sloshing from this side to this side, something like this, and the surface of water is always flat. It is given in the question. Let us say at any instant, this height, right? The original height is h throughout this particular tub. At any instant when this oscillation is happening, let us say on the right end, the water is still a height of y naught. Okay, obviously this y naught is not a constant. This is water will slosh from this side to on this side from some depth to some height, right? Something like this, right? At any instant, I'm assuming it is v naught. Obviously, v naught is a variable. At a particular instant, I'm saying the height is v naught. Right. So now for finding the potential energy or change in potential energy, let us say when the water is at, in this particular scenario, let me say the potential energy is 0, right? I'm taking that as a reference and I have to find the potential energy in this particular scenario. Okay, so I will assume that the length is already given 12. The height of water column is the actual height, that is h. My y naught is obviously very small compared to h. Let me assume that the breadth here is right. So I have a tank something like this. So let me assume this breadth is b. Okay. So what will be the volume of this whole water body? That will be length is 12, height is h, and breadth is b. That will be the volume of this whole particular system. Right now, what I have is in this particular scenario, I have to find the potential energy. That means I have to get the center of mass of this particular. This will be like a prism, right? This section of water will be a prism of very small height y naught. Okay. So essentially, I can assume water from this part has to find energy as shifted to this part. Everything else remains as it is, right? So I have to find potential energy, I need mass of this particular section, G into whatever this height of the center of mass will be, correct? So that will be what will be the mass of this particular system, density into volume. What will be the volume of this particular section? Then the height is h, this length is L, 2L ka adha L, and this height is y naught. Okay, now the center of mass of this prism, I only want the position of this y coordinate, right? Yeah, height. Okay, and from here it has risen till this particular point. Okay, so obviously that will be same as the center of mass of this particular triangle, right? Because lots of layers of such triangular layers that will complete my whole prism. Okay, so I have to find the center of mass, only the y coordinate, or only in vertical direction I want to find the center of mass. That will obviously be centroid of this triangle. And what will be the coordinate, y coordinate of the centroid? See, this y is 0. Let us say this y is 0. This is also 0. This is y. Right? So 0 plus y by 3. That means this length will be y naught by 3. Right? So how high has this particular water risen? Will that be y naught by 3 or 2 y naught by 3? So from this particular point, I am assuming this section has moved to here. Everything else is as it is. So what is the change in potential energy? Density into 2 times. I will do 2 times because this is also here also I have the same height what I have here, right? Capital H. So my answer will be 2 mgh, not 2 mg capital H, right? So that is 2 times m density into volume. I want volume of this section. That will be area of this into breadth p. So half base is L, height is y naught, and half base into height into b, right? Into b. Okay, this is the mass into rho, that will give me mass into what is this height h, that is you have already seen, this is y naught by 3 into y naught upon 3. Okay, this will give me the potential energy taking the original scenario as 0, right? So this will become what? This is rho L B G upon 3 into y naught ka square. And this is my potential energy in this particular scenario when my water is in this state. Okay. It has fallen down by y naught and it has risen up by y naught. Right? The potential energy part is very basic thing. Right now, coming to the kinetic energy part, we have to be a little bit careful. Okay. So before going to the kinetic energy part, obviously different. I can divide this particular liquid column as different such layers. Every layer will have different speed, right? Every layer will have different speed. Obviously, we are assuming the speed is in this direction. That means horizontally rightward, because this height is very small. We are neglecting the vertical velocity. All right. Now, water is rising. Obviously, every layer. If I consider this particular layer, okay. So when the oscillation is happening, this layer's height increases, then decreases, then increases, and then decreases. Similar to what will happen in the edge layer, right? In this last layer, obviously it will be oscillating something like this. Okay, we will consider oscillation of this particular, say, length across the side wall. Okay. So what we have assumed that a particular height at any instant, the edge height is y naught, right? So water on the wall is at a depth of y naught from h, right? From this value h, okay, at this particular instant. Obviously, now what I will do is let me consider. Okay, and also what about the speed? Which particle will have minimum speed? The particles which are in touch with this layer, right? They cannot move. Obviously, they will have minimum speed. Say the speed at the center, this particular part. Say that particular speed is v naught, right? I have to find the total kinetic energy of this whole section. Okay. So let me assume at a distance x from this mid part, let me consider a layer of thickness dx. Okay. Obviously, height of this particular from that height h, this value will be obviously less than y naught. Let me say this value is y. Right. What is the relation between y, x, L and y naught? That relation will obviously be y naught by capital L is y upon x. So what will my y be equal to? Y naught by capital L into x. Obviously, for this particular layer, x is constant, right? For this particular layer, x is constant. For a particular x, we are considering a layer which is at a height of y from that particular edge, when the edge layer is at a height of y naught, right? The edge layer in the sense the layer which is in touch with the wall. All right, now be a little bit attentive here, right? Say the speed here, say that speed is v, right? Water is obviously sloshing from this side to this side, right? So different layers, different particles will have different speed. Say this particular, say the particles entering this particular layer, say they have a speed v, and those exiting this particular layer, say they have a speed of v plus dv. Okay, now the term dv, right, is that positive or negative? Obviously that will be negative because As we move away from the midpoint, my speed will keep on decreasing. And this particular layer, which is in touch with the edge wall, that has zero speed, right? Obviously, my term dv is negative. All right, now what is the height of this layer? This is almost h. Okay. So how much volume is entering this layer? Okay, different volume will be entering and different volume will be exiting, obviously, right? That is the reason why this particular layer's height will increase and decrease, right? And this layer's height will also increase and decrease. So different volume is entering and some other volume is exiting, obviously. That will cause what? That will cause change in this particular layer's height. Say because of that entry or exit, let me assume that it is increasing. I'm assuming the speed v is greater than v plus dv, right? When the water is, when this layer is moving up, this layer will also move up. Let us say due to this variation here, due to this difference in say liquid entering and exiting, that is why this volume is changing and this layer, this say the height of this layer is increasing, right? Let me assume at any instant, of time, those the speed of particles entering is v and those exiting is v plus dv. Right, now what is the rate of flow? You already know that the rate of flow is a into v, right? Rate of volume flow in equation of continuity, you have seen a into v, right? Now what is this cross section? This cross section will be, let me say, a rate of volume flow for this particular layer, right? This volume is increasing and decreasing, right? That is what is causing this change in this y, right? Anyway, the rate of volume flow will be what? A into v. So what is the area here? Area here will be, this length is h, approximately h, right? Breadth is b. So area is h into b into v, right? This is a into v minus, because this is entry part and this is exit part, minus areas again same, h into b, but I have assumed the speed is v plus dv. My dv term is negative when this volume is increasing, right? Larger speed, larger volume is entering, lesser volume is exiting, hence this particular liquid rises, right? In this particular layer there is a rise in liquid. All right, so rate of volume flow will be hb into v, term gets cancelled, hb into dv. This dv is change in speed or difference in speed at any distance x, and minus of that. Okay, and due to this particular extra volume inflow, this there is ये भाई water इसमें ऊपर उठेगा, ठीक है? तो वो जो ऊपर उठ रहा है उसको मैंने dy assume किया है, उसके हिसाब से अगर मैं d वॉल्यूम लिखता हूँ, dy ऊपर उठने के कारण जो इंक्रीज इन वॉल्यूम होगा वो कितना होगा भाई? ये लेंथ कितना है dx, this is increase, that is dy into breadth is what b, right? So I can write that as b into dx into dy, ठीक है? And from here d volume by dt, that will be b into dx into dy upon dt, ठीक है? So I will equate this term and this term. So my equation minus h d into dv, which is change in velocity, and I'm talking about say at different x, the change in velocity at any x is dv. So minus h b into dv is equal to b into dx into dy by dt. Obviously, when my dv is negative, the height will increase, my dv by dt will be positive. Anyway, the relation I get here is minus h into dv is equal to dx into dy, right? Now for different elements, this y is different, so I'll keep my y in terms of y naught, which is the height of the last layer. At an instant, this height is y naught for every layer, whatever layer I consider, this large layer is having a height y naught, right? So instead of dy by dt, what can I take dy by dt as? Dy by dt will be what? dy naught by dt upon L into x, right? Dy by dt for any layer here, that will be dy by dt will be equal to x. For that particular layer, x is constant, L into dy naught by dt. So instead of dy by dt, I will substitute that particular term as dy naught by dt upon L into X, right? So the relation I have here is dV is equal to minus that H. Let me move it to the other side. That will be H into L minus H into L into X dx into dy naught by dt, right? So this is change in velocity as a function of X at the instant when the edge layer, right, that layer's height is increasing at the rate of dy naught by dt, right? This is the only equation we need to further solve this particular question. Right now, what I have assumed that speed of the mid section, that means when x is equal to 0 is v naught. Let me try to get the value of v naught also. When I integrate this, I will integrate it from v naught to v, right? And this will be from 0 to x. That integration will give me v minus v naught is equal to minus 1 by h into L is constant. At a particular instant, this dy naught by dt is also constant into x. Well, it is increasing whatever this rate is, that is constant for all those sections, right? Into x into dx integration will be x square by 2. 0 to x will still give me x square by 2. So what I have is v equal to v naught minus x square by 2h into L dy naught by dt. This is my speed of any layer which is at a distance x when the center layer has a speed of v naught and the edge layer, that edge layer's height is increasing at the rate of dy naught by dt, right? So I will keep all my say terms in terms of y naught, right? Because I have gotten the potential energy also I have got in terms of y naught. So now I've got this kinetic energy. And how will I get the value of this V naught? How do I get the value of V naught? That is simple. When x is equal to 0, sorry, when x is equal to 0, my V is V naught, right? What about when x is equal to L, at the edge layer, right? At the end of this particular term, what will be what will be the speed of the particles? That will obviously be 0. When x is equal to 0, V का value क्या होगा भाई? आपका 0 हो जाएगा. तो 0 लगाइए, equal to v naught minus L square by 2h into L. That will give me L upon 2h, right? L square, एक L कट गया, into dy naught by dt. So my v naught is L upon 2h into dy naught by dt. So my speed of any particular layer when the edge layer is increasing with the speed of dy naught by dt, that speed is how much? L upon 2h dy naught by dt minus x square by 2h into L into dy naught by dt, right? This is the speed of any layer, any say particle which is at a distance x from the center, right? Now, how do I get kinetic energy? Kinetic energy is half mv square. different x पे भाई आपका speed different है. तो आप फिर से यहाँ पे ये consider कीजिए. What I have, let me consider kinetic energy of this particular layer, right? Whose height is almost equal to h. ठीक है? What will be the volume? Mass will be density into volume. Only this particular layer's volume, right? Again, height is h, this thickness is dx, and breadth is b, right? That is density into volume, h into thickness is b into dx. ठीक है? And इसका speed कितना है भाई? इस particular layer का speed ही हमने ये रहा निकाला है. तो v का value क्या आ रहा है? L upon 2h minus x square by 2h into L, x square by 2h into L into dy naught by dt. ठीक है, ये स्पीड है इस पर्टिकुलर पॉइंट पे. भाई काइनेटिक एनर्जी क्या होगा इस पर्टिकुलर सेक्शन का? ओनली इस पर्टिकुलर सेक्शन का. ठीक है, काइनेटिक एनर्जी क्या होगा? हाफ mv स्क्वायर. तो डी के ई मैं लिखता हूँ हाफ इस पर्टिकुलर मास का, इस पर्टिकुलर एलिमेंट का मास डेंसिटी इंटू वॉल्यूम एच बी डी एक्स इंटू वी स्क्वायर, ठीक है, इस टर्म का स्क्वायर, कोई भी एक्स वाला लेयर के लिए आपका डी वाई नॉट बाई डी टी तो सेम है, तो इसका स्क्वायर करेंगे तो क्या आ जाएगा, देखिए वो हो जाएगा एल स्क्वायर अपॉन टू, टू का स्क्वायर 4 एच स्क्वायर, सेकेंड टर्म एक्स पावर 4 अपॉन 4 एच स्क्वायर एल स्क्वायर माइनस 2 ab माइनस 2 एल अपॉन 2 एच इंटू एक्स स्क्वायर अपॉन 2 एच इंटू एल, ठीक है, इंटू ऑब्वियसली डी वाई नॉट बाई डी टी का होल स्क्वायर। अब इसका इंटीग्रेशन मुझे करना है काइनेटिक एनर्जी के लिए, मैं क्या करूँगा 0 से एल तक करूँगा, इंटू भाई इधर वाला लिक्विड का भी कहानी वही है तो इंटू 2 कर देता हूँ, ठीक, 0 से एल या माइनस एल बाई टू से एल बाई टू तक कीजिए, मैं 0 से एल कर रहा हूँ तो इंटू 2 कर दिया, तो दिस विल मी गिव मी काइनेटिक एनर्जी, तो ये कितना आ रहा है भाई रो एच बी डी एक्स, अच्छा और क्या दिख रहा है 4 एच स्क्वायर 2 एच इंटू 2 एच, यहाँ पे भी 4 एच स्क्वायर दिख रहा है, राइट, तो फिर ऊपर क्या बचेगा, ऊपर बच रहा है एल स्क्वायर डी एक्स, आपको 0 से एल तक करना है जो कि क्या हो जाएगा एल क्यूब हो जाएगा, प्लस 1/L स्क्वायर, राइट 4 एच स्क्वायर कॉमन ले लिया था, 1/L स्क्वायर इंटू एक्स पावर 4 dx, सही है, ओके, फिर क्या है माइनस 2 एच स्क्वायर कॉमन ले लिया था, ये एल आपका कट जाएगा तो माइनस 2 बचा है एक्स स्क्वायर डी एक्स, ठीक है, तो इसका इंटीग्रेशन मुझे करना है फ्रॉम 0 टू एल एंड दिस विल गिव मी काइनेटिक एनर्जी, तो देखिए भाई फिर ये क्या हो रहा है रो एक एच कट गया, रो बी अपॉन 4 एच डी एक्स अंदर ले गया हूँ, इंटीग्रेशन करने के बाद एल, ये एल क्यूब हो जाएगा प्लस एक्स पावर 5/5, वो तो एल पावर 5/5 होगा तो वो हो जाएगा एल क्यूब बाई 5 हो जाएगा, माइनस 2 एक्स डी एक्स एक्स स्क्वायर डी एक्स इंटीग्रेशन एल क्यूब बाई 3, ठीक है, तो ये क्या हो रहा है 1 प्लस 1/5 माइनस 2/3, 15 ले लेते हैं तो 15 प्लस 3 माइनस 10, 18 माइनस 10 आपका हो जाएगा 18 माइनस 10 इज 8 अपॉन 15, तो ये हो जा रहा है तो बी अपॉन 4 एच हो जा रहा है 8 अपॉन 15 एल क्यूब, अच्छा वो डी वाई बाई डी टी का होल स्क्वायर वाला टर्म तो है ही है, राइट, ऊपर भी है एंड हर जगह है वो ना, डी वाई बाई डी टी का होल स्क्वायर वाला टर्म, डी वाई नॉट बाई डी टी का होल स्क्वायर, ठीक है, तो ये हो गया भाई आपका काइनेटिक एनर्जी एंड इससे अपना क्वेश्चन सॉल्व हो गया है, तो माई काइनेटिक एनर्जी इज फॉर टू कटेगा 2/15, क्या है फिर रो है आपका बी है, ऊपर एल क्यूब है इंटू डी वाई बाई डी टी का होल स्क्वायर और नीचे एच भी है, राइट, सो दिस इज माई काइनेटिक एनर्जी, ये रहा भाई काइनेटिक एनर्जी निकालने का, तो यही थोड़ा सा टफ पार्ट है इस पर्टिकुलर क्वेश्चन, ठीक है, अब ऑब्वियसली क्या है भाई टोटल एनर्जी आपका कांस्टेंट है, टोटल एनर्जी फिर आपका क्या हो गया, ये हो गया काइनेटिक एनर्जी 2/15 एच रो बी एल क्यूब डी वाई नॉट बाई डी टी का होल स्क्वायर प्लस पोटेंशियल एनर्जी क्या था, पोटेंशियल एनर्जी लेट मी कॉपी पेस्ट, तो आपका पोटेंशियल एनर्जी ये रहा, ये आपका पोटेंशियल एनर्जी, राइट, तो ये भाई स्टैंडर्ड इक्वेशन हो गया, फिर दिस इज पोटेंशियल एनर्जी, इस इक्वेशन को देखिए स्टैंडर्ड एसएचएम का इक्वेशन है, सम कांस्टेंट लेट अस से ये कांस्टेंट ए है, डी वाई नॉट बाई डी टी का बताया था वो वाई नॉट का ऑसिलेशन ही हम कंसिडर करें, प्लस बी इंटू वाई नॉट का स्क्वायर इक्वल टू कांस्टेंट, राइट, तो इसका एंगुलर फ्रीक्वेंसी ओमेगा क्या होगा भाई, ओमेगा हो जाएगा बी बाई ए, तो अपना ओमेगा क्या हो जा रहा है, अपना ओमेगा रो एल बी जी अपॉन 3, फिर यहाँ क्या आ जा रहा है 2/15 एच रो बी एल क्यूब, ठीक है, तो ये आपका ओमेगा है, 3 5 कट जाएगा, आपका एक एल कट जाएगा, ये बी कट जा रहा है, राइट, तो क्या हो जा रहा है फिर ये रो आ गया ऊपर, जी आ गया, नीचे से एच आएगा, सॉरी रो तो कट जाएगा, यहाँ पे भी आपका रो है, ऊपर जी इंटू एच आ रहा है और नीचे क्या आ रहा है 3 5, ऊपर 5 भी जाएगा, 5GH अपॉन नीचे बच जा रहा है 2L³ का एक N स्क्वायर, राइट। दिस इज ओमेगा। आपका टाइम पीरियड इज 2 पाई बाई ओमेगा, तो 2 पाई अंडर रूट तो हो जाएगा 2L स्क्वायर अपॉन 5GH, राइट। तो दिस इज माई आंसर। टाइम पीरियड कितना है? 2 पाई अंडर रूट 2L स्क्वायर अपॉन 5GH।